Hi students, this is class number 3 where we are going to solve another problem based on block diagram reduction. Problem number 2, little complicated. This is an LAQ you can expect in the external exams. So they will give the block diagram, they will ask to find the transfer function of the given block diagram, that is C by R we need to calculate. Okay, first I will draw the problem. You also draw along with me so that it will be time saving and you will get practiced. So here we have more number of summing points in this problem. We can give the numbers to the summing point so that it will be easy when we solve. In this problem around 4 summing points are there. This is G1 and another summing point here we have plus and minus, and then here we have G2, then again the forward path G3, then we have the summing point here, then we have the output C finally. Okay, so here you can observe this is not complete problem, I am just explaining. G1, G2, G3 are in forward path. Okay, now further the given problem I am drawing here. So between G2 and the summing point we have G4 block, number G4, which is given to the last summing point here. Here it is plus and plus. Okay, and then between G2 and G3 also we have a break point, or it is called as take off point. We can call it as branch point or take off point. This is, it is coming from output towards input, that you have to be careful, which is called as forward path, which is called as feedback path. Very important. From the output towards input we are getting, so that is nothing but it is in forward feedback path. Here from the output towards input we are taking, so it is in feedback path H1, and it is connected to negative, so it is in negative feedback. And for our understanding we can take the numbers to this summing points 1, 2, 3, 4. It will be easy to solve the problems, not compulsory or required that we have to give the numbers to the summing point. If you want you can give, it will be easy while solving the problem. Okay, here negative feedback, another we have H2. This given problem it is which I am drawing here. So here from the output we are taking towards the input, this is H2. From the output towards the input we are taking it as H2. And now another feedback we have where we don't have any H1 or H2, just unity feedback it is called, which is also taken from output to input. This is unity feedback. So totally here we have 3 feedbacks. One is with respect to H2, another is with respect to H1, another is unity feedback. 3 feedbacks here we have, and 1 forward path with respect to G4. And what the problem they are asking is find C by R, that is called as the transfer function of the given complete block diagram, output by input they are asking to find. So we have to adjust the location of the branch points, which are called as takeoff points, by observing the block first. If you observe, you can see here between G2 and G3, between G2 and G3 we have this branch point which we are taking as feedback towards the input, so it is in feedback with H1. Suppose if we move this branch point from between G2 G3 to before G2, between G2 to G3 before G2, if you move the takeoff point, then G2 G3 comes in series, and that will be in forward path with G4. So overall these 3 will be simplified, that is G2 into G3 plus G4. So all these will be simplified in a G2 into G3 plus G4 we get. So we will be shifting this takeoff point between G2 to G3 to ahead of G2. So first you have to observe the block diagram, then you have to do the adjustments. Okay, so we start the solution here step wise. Step number 1 will be doing now. What is step number 1? You can write it here, that is moving the branch point that is between G2 and G3, moving the branch point before the block G2. Before the block G2 we are moving the branch point, or also called as takeoff point. So after moving that, I am drawing the block diagram, that is after moving this takeoff point between G2 to G3 to before G2, now I am drawing the block diagram. Again we have to draw this because to solve the problem we have to have number of steps. You practice more number of times, it will be easy. So here we have two summing points 1 and 2, then we have G1, then we have another summing point 3 plus and minus here. So here we moved the branch point ahead of G2 here. So between G2 and G3 now we don't have any takeoff point between G2 and G3, and that is connected to the summing point. And here we have the output C, this is plus, and from this point we have in parallel, that is G4 is there, which we have not done any changes, that is connected to the summing point 4. And when we moved the takeoff point or branch point from between G2 to G3 to before G2, we are losing the gain of G2. When the takeoff point is present, between G2 and G3, we are getting the gain of G2 also. We are getting the, I am drawing, you can see here, I will just erase this. So when we are taking the takeoff point between G2 G3, the gain of G2 also added to this. But when we moved the takeoff point from between G2 to G3 to before G2, we are not getting the gain of G2 if you don't make any adjustment. So to get the gain of G2, we are going to add G2 along with the H1. So this is the adjustment we are making. So whenever, this is another rule which we have seen already, that whenever we are moving the branch point before the block, we have to add a gain of that G2 along the already present H1, right. So this is H1 and we got in G2. Remaining everything we are going to draw the same way, there will be no change here. We are going to this H2 and we are taking the output from this point, output, and this is unity feedback also we are taking. Here we didn't made any changes for unity feedback or H2, only the modification or adjustment we have done by moving the branch point from between G2 to G3 to before G2, so that this G2 into G3 comes in series, these two, and to that G4 comes in parallel, right. So that block diagram we are going to draw, that is G2 into G3 because they are in series, plus G4 because G4 is in parallel path, forward path, and both are here plus, right. So that will be the step 2. We are going to write again. You have to draw. There is no other option. That what little tedious it looks to draw every time these summing points and this. Okay, that is a part of solving the problem, because it is an LAQ. You get full marks, 15 or 12 or 10 marks. So it is, you have to draw every time we solve this, right. So these are the summing points, and one summing point that vanishes now is summing point 4. Summing point 4 will vanish. This is 4, 1, 2, 3. Summing point 4 will vanish because we are using that G2, G3 plus G4 we are added. So summing point 4 will vanish. Remaining 3 will be present. So we write this as G2, G3 as I said plus G4. G2, G3 plus G4. I am explaining little slow so that it will be clear. Okay, now here we have the feedbacks. We have not disturbed the feedbacks. Total 3 feedback paths are there. One is with respect to H2. We are taking the same. We have not disturbed this. And another feedback is this one, unity feedback, which is given to the starting summing point 1, 2, and this is 3. Another feedback we have, that is with respect to H1, in which we added the gain of G2 because we have moved the break point ahead of G2, right. So this is the block diagram what we get. Now some adjustment again we are going to do here is moving summing point before the block. Now we are going to move the summing point 3 before the block G1. Summing point 3 will be moved before the block G1. That will be our step 3. So I will write that step. Moving summing point 3, if you give the numbers, moving summing point 3 before the block G1. We are moving the summing point 3 before the block G1. We have to do the some adjustments when we move the summing point before G1. So that I will draw here. Again we will be drawing that block diagram. Moving the summing point before the block. Okay. So here you can combine this H1 G2 into a single block because these two are in series. So you can write it as H1 in G2 in this step itself, or in the next step also you can write it as H1 G2. Okay. And here we are moving the summing point ahead of block G1. So whenever we move the summing point ahead of block, what we have done earlier is we have added a new block of 1 by G1. You can understand that property or rule number 6 we have, where we move the summing point before the block, we have to add a new block of the gain 1 by G1 where we have moved. So we will be adding that gain of 1 by G1 in that block I am drawing now. There is a rule that whenever we move the summing point ahead of the block, we will be adding a new block of 1 by G1, right. So I will draw that block diagram. Plus minus it is, and here also we have plus minus, and here we have G1. You can see that the summing point 3 now it is shifted before the block G1. It is earlier it is after G1, now it is before G1. Now here we have the feedbacks. So since the summing point is moved before G1, we are adding a new block of 1 by G1. This is the rule which we have seen. I'll explain why we are adding here a new block of 1 by G1 in series with H2. And this is already it is there G2, G3, G4, and this is connected to output C, and from this output we are getting this H2. This is one feedback. All the feedbacks we have not combined. So here we have H1, G2, both are in series. From the output towards input it is going, so we call it as feedback. And this is also from output, sorry, it is I have drawn output, this is one. From output to it is going towards the input, right? So it is also feedback. Now one thing I will tell why we are adding this G1 here is, earlier the summing point is here, earlier before we shift this is, so along H2 we are not getting the G1 gain earlier. H2 into G1 we didn't had. Now if we don't add this 1 by G1 and if we just shift the summing point, H2 is in feedback. When it comes like this, the signal, the G1 gain will be added to H2, which is not correct. So what we are doing here is, we are adding 1 by G1 so that the effect of G1 which is coming into H2 because of shifting the summing point ahead of G1 will be nullified. So we are adding this new block of 1 by G1. So this is a rule number 6 which I have explained class number 1. Whenever we move the summing point before the block G1, we have to add a new block of 1 by G1, right? Remember that rule, moving the summing point ahead of the block. So now here this G1 and this G2, G3 plus G4 are in series. Here we have small correction, that this H1 G2 is coming between G1 and G2 G3. So these are in series if this takeoff point is not there, but here we have the takeoff point. So between G1 and G2 G3 plus G4 we have this takeoff point which is connected to H1 G2. Okay, this is after shifting the summing point. Now we will be interchanging the summing points 2 and 3. Just interchanging the summing point, and you have to remember the rule that whenever we interchanging the summing point, there will be no new blocks will be added. No need of adding any new blocks whenever we interchange the summing point. Interchanging the summing points 2 and 3. Interchanging the summing points 2 and 3 is the next step. And modifying the branch points. So when we interchange, it will be simplified in single shot. So whenever we shift the summing point, this 3 to in location 2 and 2 to in location 3, just we are bringing, then the block will be simplified. It is single step and we get the new block which I am drawing now. Again you have to draw the block completely after doing the adjustment. So this is unity feedback which we had with the output. Now here we are adding the summing point 2 we have. Next we have summing point. So this is 1, this is 3, this is 2. We have interchanged the location of the summing points. We have interchanged the location of the summing points. So we had G1 and here we had G2, G3 plus G4, G2, G3 plus G4, and here we have the output C. And now between G1 and G2, G3 plus G4 we have the feedback of H1 G2, and that is given to summing point 2. We have interchanged the location of the summing points. Now this is unity feedback which we have taken this one, and now to this summing point 3 we had this H2 by G1. This is at the output, right? So what is the advantage of, what is the use of shifting the interchanging the summing points 2 and 3 is, you can see here after interchanging the summing point, G1 and H1 G2 can be simplified. H1 G2 is in negative feedback with G1. With G1, H1 G2 is in negative feedback. So we can simplify this as G1 by 1 plus G1 into H1 G2. To that this will be simplified, and that one is in series with G2 G3 plus G4. Okay, so this complete G1 H1 G2 to G1 H1 G2 is in negative feedback. So we can use the rule number 10 and we can combine this G1 block with H1 G2 in negative feedback, and we write it as G1 by 1 plus G1 into H1 G2. This we get combined negative feedback. To that block which I have done with the blue color I have circled, to that block which is G1 by 1 plus G1 H1 G2, this G2 G3 plus G4 is in series, so we can multiply this one with our G2 G3 plus G4, because after simplifying the negative feedback G1 by 1 plus G1 H1 G2, to that this G2 G3 plus H4 is in series, so summing point 2 will vanish and that block is in series with G2 G3 plus G4. So we combine that and we'll write it as a single block now. So again I am going to draw this. Summing point 1 is there still, summing point 1 is there, and summing point 3 is also there. 2 we have combined, this is plus minus, and here this block which we got here we are going to draw this big one which is G1 by 1 plus G1 H1 G2 into G2 G3 G4, right? So big one, and here we get it as output connected to C. Now here we have the feedback connections, another two. Okay, it is a long lecture. H2 by G1 is in feedback, again unity feedback is there. It will be done in next 10 minutes, also less than that time, don't worry. It is I'm thinking a little more slowly, because the starting problems it requires to be explained very slowly, otherwise you won't understand. So we have the feedbacks with the output, that is H2 by G1 and unity feedback, right? Now it is very carefully you have to understand. Here is the point, I'll change the color. This is a complete block of G1 by 1 plus G1 H1 G2 into G2 G3 plus G4. To this block, this H2 by G1 is in feedback. That is what is the thing. So this complete which I am circling here is, you can take it as capital G. To that capital G, this one H2 by G1 is in negative feedback. So we can combine these two blocks using the rule number 10, and we can write it as in a single block, and summing point 3 also is going to vanish. Okay, again I am explaining, G1 by 1 plus G1 H1 G2 into G2 G3 plus G4, we are taking it as capital G, that is to that capital G H2 by G1 is in negative feedback. So we are going to combine this capital G and H2 by G1 in negative feedback. So what we get here is G by 1 plus capital G into H2 by G1, we get this, where capital G is this G1 by 1 plus G1 H1 G2 into G2 G3 G4, that is capital G. Okay, summing point 3 vanishes. So I'm writing the new block here. Summing point 1 is still there, summing point 1 is there, input we have, and we have a big block of I'll write here G, okay, G by 1 plus G into H2 G1, where G you have to substitute, it is better to substitute the values here, which is nothing but G1 by, okay, G1 by 1 plus, otherwise at the end we will write now G by, for now G by 1 plus G into H2 G1, right, and output C. And the last feedback we have is unity feedback, which is connected to the summing point 1, and the 5 minutes will conclude. Now to this complete block of blue box which I have done now to blue, to that this unity gain feedback is negative feedback. So we will be combining these two using the rule number 10, and we get a big block. So now this complete G by 1 plus G H2 G1, you can take it as some X, okay, we can take it as X. So we write it as X by 1 plus X into 1, right, G by 1 plus G into 1. So in place of G here we have X, so we write it as X by 1 plus X into 1. This is C output. So finally we get C by R, output by input is nothing but X by 1 plus X. This will be the final, but here you have to substitute what is X. First we will substitute that. What is X we have here is G by 1 plus G into, you have to finally simplify H2 by G1, this is our X, whole divided by 1 plus G by 1 plus G into H2 by G1, okay. So this is X, this is X, this one. Now you can take the LCM here for the denominator, and we can cancel 1 plus G into H2 G1. So you can write here it as G divided by, for the numerator, 1 plus G into H2 by G1. This is our numerator, right, and whole divided by, in the denominator we are taking the LCM now. So what we get is 1 plus G into H2 by G1 LCM, okay, 1 plus G into H2 by G1 plus capital G whole divided by, we have 1 plus G into H2 by G1. Don't be sleepy, it is, so you can cancel this and this, 1 plus G into H2 by G1. Finally we can write it as capital G in the numerator, okay, divided by 1 plus G into H2 by G1 plus capital G. Now you have to substitute what is capital G also, not just leaving it as capital G. What we have taken capital G here is G1 by 1 plus G1 H1 G2 into G2 G3 plus G4, that is what we have taken it as capital G. So that you have to substitute here. Finally that has, the simplification has to be done because it is a long answer question. So I am writing what is G here, G1 into G2 G3 plus G4 whole divided by 1 plus G1 G2 H1, right, whole divided by 1 plus, here we have G, again you have to write this you write. Okay, it is simple only. You may feel that why is G also this one only. This is your G. Okay, finally you write and do the simplification. We get the answer here. Capital G, little complicated is G1, G2, G3. Plus you try this. If you don't get, I'll solve later. I want to conclude this finally because it is a long time. It has already G1, G2, H1, G2, G3, H2 plus G4, H2 in the denominator itself G1, G2, G3 plus G1, G4. This is our C by R. Okay, so this is our final answer, which is nothing but transfer function. So try to substitute the G values in this and G and simplify this. Thank you for watching. Please subscribe and share the झालं तर